And I'm going to do a formal introduction now. So welcome everyone. Good afternoon. My name is Emily Bucco. I'm one of the counselors that works here in the admissions office at WPI. Congratulations to all our admitted students joining us this afternoon. We're happy to have you here for the Department of Mathematical Sciences information session. So welcome, welcome. As I mentioned, we are using the webinar format for Zoom. So hopefully you guys can see all of us. What we're going to have you do as the session progresses, we have the Q&A option open. Please feel free to drop some questions in there as we go throughout, so we can go ahead and save time at the end to answer those, or answer as we go. We'll just see how that feels. But without, what I'm going to do is I'm going to turn it over to our fantastic Department of Mathematical Sciences. I'll let you guys go ahead and introduce yourselves. I don't know, Marcella, if you want to go first, and then we'll go from there. I'm going to stay here, but I'm going to turn off my camera and help you guys monitor the Q&A from behind.
Everybody, welcome. I'm Marcel Blaise. I'm a faculty member in the Mathematical Sciences Department and the Associate Department Head, and I'm looking forward to talking with you about studying with us.
Yeah, sure. I'm Forrest. I'm a junior math major at WPI, and I'm also a double major in data science.
Hi everyone, Sarah Olson, currently the Department Head of Mathematical Sciences, and we are super excited to have you join us on this webinar this evening. Please utilize the questions. We're happy to answer throughout the talk, and we'll be kind of monitoring that and happy to answer any questions as we go through this. So hopefully we're going to tell you a little bit about the department and some of our activities and all the great things that we have going on here, and then save some time at the end for you to ask any questions as well as during the presentation. So I like to kind of start with why study mathematics. There are lots of reasons to study math. Math is cool, math is fun, math is actually really useful. You can get a job, all great things. So here I have kind of just a picture of a graph, or what we would call a network, in terms of what happens in the mathematical sciences. We're very interested in kind of how these things are connected, the weights, how interconnected, how information could travel along these edges. And then through kind of rigorous mathematics, we can start to understand how to classify these, understand different properties of these graphs or networks, and be able to understand behavior and say something kind of very rigorous about how certain graphs operate in networks, and information could flow on those. Another really fun reason to study mathematics is to think, if you're drawn to logical analysis, patterns, structures, when we start looking at some of these graphs or networks, you can kind of already start seeing some of the patterns and the edge connections. The other great thing about mathematics is, right, it's just this kind of language, the way we can describe things very formally or rigorously. We can use this language to describe things in science and engineering, biology, physics. But what we can really do is think about kind of how to optimize something, how to minimize something, how to maximize something. We can make predictions. We can understand how a small change in a system, if you remove an edge on one of these graphs, what happens? How do things connect? So we can do lots of that through kind of the mathematical tools that we develop in our courses. And one of the great things to really emphasize is that mathematics and statistics is at the core of modern science. And as I mentioned earlier, a wide range of job opportunities. So more than just being a teacher, although we'll talk about that in a minute as well. So in our department, we have 2 undergraduate degrees. You can get one in actuarial mathematics or in mathematical sciences. Actuaries are kind of have a specialized toolkit. I'm frozen on my thing, but hopefully you guys can still see me. So actuaries think a lot about risk assessment. So at insurance companies, they're thinking about how to assess, what is a policy for a certain age driver and a certain type car. There's assessing of that risk and quantifying that. So they're thinking a lot about that. Actuaries are going on to really great careers at Fidelity, Hanover, Liberty Mutual, Sun Life, the list goes on. This is actually a group of our actuarial students a year or two ago when they won a big competition. And they had a great photograph done, photo shoot afterwards. In addition to actuarial science, with the mathematics degree, one can certainly become a teacher and do kind of the educational side. We do not have a full teaching program in our department, but through kind of the project-based learning, students can utilize the interactive qualifying project or the IQP to do student teaching, and with kind of through the STEM Education Center, get certified to teach in Massachusetts and potentially other states. So there's always high demand for STEM focused educators. So that's always a great opportunity too, if you're passionate about teaching. Most of our students these days, when they get jobs after their undergraduate degree, the kind of common job titles are analysts, statisticians, modelers, programmers, but you can kind of see actuarial analysts, financial analysts, data analysts, quantitative analysis analysts, risk analysts. So many of the job titles involve the kind of word analyst because you're analyzing things or kind of making conclusions, analyzing these different types of data. But there's kind of different core areas. A mathematician kind of really thinks about formulating these problems and either teaching or solving the problems in different industries. Statisticians are more kind of tabulating, analyzing, interpreting the numeric results. So lots of job opportunities, and I guess if you can see my mouse, also different job sectors. So it isn't just education, it isn't just government, research, industry, banks, kind of the full range. And if you're interested, there's a lot more info that you can get online at the AMS, or American Mathematical Society, that goes through different career opportunities for the mathematical sciences. In terms of WPI, we have a career outcomes reports that gets done every year. So we have very high success rates for students getting positions when surveyed right after graduating, and this data is during COVID. WPI-wide salary for a bachelor's degree is about $72,000, and math sciences and actuarial sciences are right in that range, and actuarial science is actually ranked number 4, I think, for highest starting initial salary from across campus. In terms of our department, I like to think we're a very nice sized department for a small school in terms of lots of opportunities for different courses, ability to interact with different faculty members, but we have 100, 200 undergraduate students in mathematical sciences or actuarial sciences. We have graduate programs. So there's also, Professor Williams will talk later about some BSMS opportunities and master's opportunities, but we do have graduate programs and about 50 faculty in the department. So as I mentioned, one of the great things is we're a really nice size in terms of lots of opportunities, lots of clubs, activities. Forrest will tell you a bit more of some of the activities he's involved in. But great opportunities for kind of teamwork, interdisciplinary approaches, specialized courses, and many, many activities. So one of the things that we have going on in the department is different student clubs and chapters for kind of different interest areas. So we have the ASA, American Statistical Association, that has different events and brings in speakers. Actuarial Sciences has kind of a networking night, an actuarial club, bringing in people to think about help with actuarial exams, kind of meetups, opportunities for jobs, guest speakers, kind of a range of things. We have our Association for Women in Mathematics, also doing different outreach events, as well as bringing in guest speakers to talk about their industry positions or research, different experiences. We have many different seminars that go on. We have many student activities, including Putnam exam, and maybe I'll turn it over to Forrest for a minute to tell us about some of the activities from the student perspective.
Yeah, sure. So I guess I'll start with some of the Putnam, which Professor Olson had listed. It's a international, in the sense that it includes the United States and Canada, math contest available to all undergrads throughout the country. It's a 6-hour test split into 3-hour blocks, and in between the math department takes you out for lunch, which is kind of nice. In the morning, you spend 3 hours working on a set of problems. In the afternoon, you spend 3 hours working on another set of problems. And then a few weeks later, you find out what your score is. The median score on this exam is a 0 out of 120 points. So it's really just something that you do for fun. And it's, interesting to really see what types of like competition problems you can think about and figure out. And it's a fun thing to do on that Saturday morning. Another thing that I'll probably talk a little bit about more later, but WPI has our math club, which I run, and once a week I have some activity that myself and a bunch of other people in the math department kind of come together and talk about. Usually it's like a puzzle of some form, and it's just also a good place to kind of meet other math majors and kind of have build a sense of community, which is awesome. And it's a big thing that kind of made me a math major, is attending math club and meeting the people there. And then additionally, starting this year, the math department has created this mentoring network where junior students get paired with a freshman to kind of give advice to about like courses to take, and professors to talk to about research, and navigating life at WPI and things like that.
Great, thank you, Forrest. So lots and lots of student activities, as Forrest was mentioning, a few of them: Math Club, our mentoring network, Putnam. We also bring in guest speakers here, so you can see kind of the VP of JP Morgan, fun things like Pi Day activities. Our actuarial majors are doing case competitions from different insurance companies, including Travelers. We also have kind of a series of lectures where we're bringing in every year a few guest lectures from kind of leading researchers from different institutions around the US. And they're these public lectures that kind of really survey an area of mathematics, but are kind of show you how math is interesting and the patterns that are there, without going into too much of not too much of the depth of the mathematics, but really giving you a good sense of math and its applications, and kind of the beauty and the patterns and where you can see it, and potentially analyze these things. Just to name a few from this year, we had juggling numbers and geometry, which was a really fun talk. Learned some cool things about kind of juggling geometry and math and how they're all interrelated. Another talk on dynamical symmetry, really understanding some of these snowflake patterns and different interesting mathematical techniques. Another thing that we have at WPI is a math tutoring center staffed by our very own students. So it'll be students who've taken these classes in the recent past. We often hire a lot of our math majors to work in the tutoring center or be a PLA for classes. So Forrest, maybe you can tell us a little bit more about his experiences in the tutoring center.
Sure. Yes, as Professor Olson said, I serve as a PLA, which is essentially an undergraduate TA. So this term, I'm PLAing the Calculus 3 class. So once a week, I run a discussion section, which is around 20 or so students come, and we just kind of work through problems and answer questions about things that people want to ask about that they might not feel comfortable to ask about in a big lecture setting. And it's a much more casual environment. Like the only kind of authority figure, so to speak, is myself. So it's just kind of a place for people to kind of ask questions about the courses they're taking. In addition to that, there's the Math Tutoring Center, which has no appointments or anything like that required. You just kind of walk in, you say, hi, I need help with this class, and then someone kind of helps you with whatever content is there, in addition to all the office hours and stuff that PLAs and TAs and the professors run. So there's a ton of resources for being able to succeed. And as Professor Olson said, for the people who are PLAs, it's a good chance to kind of stay sharp on all like the fundamentals and things like that as you get to move on to higher level courses.
Yes. It's great, a great opportunity for especially incoming freshmen to utilize, as well as to become a part of, kind of supporting your peers as you are a sophomore, junior, or senior, and also helps kind of really ingrain all of those mathematical techniques to have them handy for your upper level courses, which is great. So in terms of the department and kind of our areas, as we mentioned, we have mathematical sciences and actuarial science. Actuarial science is a little more defined in terms of, risk assessment for the insurance industry. Mathematical sciences, there's a number of different areas of courses and research topics and kind of expertise in the department. So one could do something very applied as a focus or something very pure. And here I'm just kind of giving you a big picture sense of some different things we have going on in the department. We have colleagues who are very interested in biological applications, some who are very interested in kind of cryptography and quantum computing, things like rigidity and flexibility of different objects, kind of on the statistics side, spatial statistics, how are things correlated? This is actually for genetic data, thinking about correlations of data, really fundamental problems of thinking about if I have data and a model, how do I relate these two, kind of what's the understanding of kind of the parameters and the model and how it's going to behave, and then most of our areas of representation in the department, as I said, kind of have a range of being applied or more pure. We also have colleagues who actually have physical labs, and they're doing microfluidic experiments and kind of doing paired experiments with kind of mathematical modeling. We have kind of a really strong department in terms of interdisciplinary collaborations and kind of affiliations in different programs. So you'll see a lot of that come into the classroom in terms of applications, motivation. You'll see some of it kind of show up in homework assignments or projects. For example, we have Professor Paffenroth, Randy Paffenroth, who uses machine learning to think about waste and chemical processes, really thinking about this whole circular economy. I collaborate with biologists, and we're thinking about division of cells and cancer cell division. So kind of really interesting collaborations, and those applications will get brought into the classroom. So we have one colleague with kind of a small scale fluid dynamics laboratory with microfluidic devices. The majority of the department's lab is more of a computational lab in the sense of doing computing of some type. And there's lots of different computing facilities across campus that students will get exposure to in some of their coursework. Okay, and now I'll let Forrest take it away with a little bit more about the student experience side.
Yeah, sure. So as I said earlier, hi, I'm Forrest. I'm a junior math data science double major. As I had mentioned earlier, I serve as a PLA for the math department. I'm also president of Math Club. My work kind of over the summers, but I'm trying to go to grad school. So that means that I'm trying to do a lot of research things so I can kind of be ready for that. And so last summer I did a National Science Foundation sponsored REU, which stands for Research Experience for Undergrads. I did this thing called topological data analysis, which is where you kind of look at the shape of the data and you see what that tells you. And then this summer, I'm going to be working on a combinatorial optimization problem for finding the optimal shelter placement for runaway and homeless youth in New York City. And kind of through both these projects, I get to kind of combine my programming skills that I'm getting from my data science courses, but also the stats and kind of math knowledge from all my math courses. And I think it's a very interesting intersection of these two areas. Some advice that I would impart that I think a lot of freshmen and first year college students don't really think about is that professors are people too, and that they're very good resources for like advice on really anything from like what courses to take, what type of like internships and things to apply to, all these types of things. And then also I think a lot of people initially don't start off challenging themselves as much as they should be. So I guess the other advice is, even if a course sounds hard, sign up for it and you'd be surprised at what you're capable of doing. And also don't be afraid of changing your major. I did that probably 3 or 4 times, and I'm still on track to graduate on time and all those things. So yeah.
Well, thank you, Forrest. And Forrest is one of our best students. Forrest is my academic advisee. So the kind of conversations he's talking about, we have had many. So thank you, Forrest. I'm going to tell you a little bit about the actual undergraduate experience, what you'll study here at WPI. And so it's important to recognize that the undergrad courses are on a 7-week term schedule. So there's 4 terms per year. And I'll talk about what you kind of work up to get to your senior project, your MQP. But first, we'll start with the first year. So most students concentrate on math, science, and then humanities or social sciences in the first year, regardless of major. And for students for math, that means calculus. And so we have 4 calculus courses, standard calculus courses, math 1021 through 1024. And that would be considered kind of the standard sequence. Most students are taking those courses. Alternatively, if you're interested in a more theoretical version for calculus, we also have the analysis sequence, which is math 1033 and 1034. And those are special versions of calculus 3 and 4 that run in A term for calc 3 and B term for calc 4. And you see a more rigorous treatment of the material with proofs. These are good courses to take if they work for your schedule, if you're interested in being a math major or an actuarial math major, or if you just like math. These are good options. We also have math 1020, which is a semester-long version of Calculus 1. So you can take that if you would like to have a version of Calculus 1 that has a little bit more of review. Okay, one question people often have is, what about the calculus that I already know? So the first thing we do is we have a math placement test that you take online at your own leisure. And we recommend that you take that at some point over the summer. It has the sole purpose of this exam is to help you find the right calculus course for you. So with that being said, there are some ways to get credit for calculus courses without actually taking them at WPI. And probably the most common is AP credit. So if you take advanced placement AB calculus and you get a 4 or 5 on the exam, on the AP exam, that gives you credit for calculus 1 and calculus 2. And so the natural thing to do if you're in that cohort is to start with calc 3 and A term and calc 4 and B term. This is a very natural cohort for the analysis sequence that we talked about before. If you take BC advanced placement calculus and you get a 4 or 5 on the BC exam, you get calculus credit for 1, 2, and 3. And then the natural thing to do is start with a special calc 4 in A term. And then there's a special cohort of differential equations in B term and our accelerated linear algebra, math 2072 in C term. If you have some calculus experience, but for whatever reason don't have advanced placement credit, we have a retroactive credit policy. And so this is very much tethered to the placement test. If you take the placement test, and it's recommended that you start in Calc 2, and you take and pass Calc 2 and Calc 3 in your first attempt in the first year, you automatically get credit for Calc 1. Similarly, if you start in Calc 3 and you take and pass Calc 3 and Calc 4 on the first attempt in the first year, you retroactively get credit for Calculus 1 and Calculus 2. So many students pursue this. After that, we'll talk about the types of courses that you take beyond calculus initially. And one of the first ones is the Bridge to Higher Math course. So this runs every D term. And this class is a course that's designed to help you think like a mathematician. So once you start to get beyond calculus, you start to see the need to be able to prove things, construct logical arguments. And this class trains you specifically in those skills. So this is a really nice course to take. Again, if you're a math major or an actuarial math major, we strongly recommend it, though it's not officially required. And again, if you like math and you feel like you want to learn more about thinking like a mathematician, this is a great course to take. After the Bridge to Higher Math course, we start to look at what we call transition courses. And these are the courses that help you kind of level up in your math studies. You're getting beyond calculus and you're starting to branch out into different areas of math. So these courses are teaching you those skills about proving things and working like a mathematician, but at the same time, you're getting experience in kind of feeling out the world of math. There is a lot of math out there, and our department, I like to say, has a very rich catalog of math courses. So being a math major at WPI means that you have to choose the courses that you're interested in and specialize. It's not a place where you can just take all the math courses. There are far too many to do so. And these courses start to give you a sense of the type of math that you might be interested in. After those, you start to take your upper level courses, you specialize, and that's where you are along the way getting to know your professors. And as you get to know your professors and the type of math you're interested in, that guides you towards your major qualifying project. And so your major qualifying project, oh, I should mention also, we also have special topics courses. And these special topics courses run usually once a year, and we poll faculty and we poll students and we find something that is of interest to both groups. So this year, right now, we have a special topics course on analytic number theory running. And next year, there's a couple. We have a time series course and a course called Spectra of Graphs running. For the actuarial math majors, there are special courses, and so they're listed here. And our actuarial math major is designed specifically around the actuarial exam schedule. So there are two societies for actuaries, two professional societies, the Casualty Society and the Society of Actuaries. And both groups have their own sequences of exams that you pursue to get designated as an associate and then possibly as a fellow of these societies. And so we have these courses listed here, which are specifically designed to prepare you for those professional examinations. For the exams, we typically have actuarial math students graduating with 2 industry exams. About a quarter of the students are completing 3 industry exams and some VEE credit. And the record is 4 industry exams. Professors Abraham and Postero are our faculty members who direct our actuarial math major, and they both are very connected to the industry. Professor Abraham is a fellow in the Society of Actuaries, and Professor Postero is an associate in both the Society of Actuaries and the Casualty Actuaries Society. And it's also worth mentioning that Professor Abraham is on the exam committee for some of these actuarial exams. So you really are seeing, you really are getting great expertise. To talk about the major qualifying projects, again, this is WPI's lingo for your senior project. What's pictured here is an annual event that we have, our Pizza and Projects Day, where the students and math faculty meet, and math faculty present about different project opportunities they have and then network with the students. But it's important to recognize that in addition to this, you are meeting professors, you're working with professors, you're getting to know people. So there are many different opportunities to have an MQP. For the details, you work closely with a faculty advisor or a team of advisors. It also may be individual as a student or as a group. And it's a 3-course equivalent. So you can think of that as, if you did it in one term, it would be all of your coursework for a term, or what's more common is to have it spread out over 3 terms, where it's roughly equivalent to 1 class per term. And As Professor Olson had mentioned before, the different research that people are doing in our department, there is a very wide variety. We have around 40 full-time faculty members, and they're all doing very interesting things. And all of us faculty are excited to work with students. We're at WPI because of this project-based learning focus. And so everyone who's here is really excited to do this. It's also worth mentioning that some MQPs do result in publication. And so that's a nice benefit as well if you're looking to, say, go to graduate school after your undergraduate degree. And if you go to the link here, you can look at some past MQPs to see examples of these. We also have opportunities for industrial MQPs. So we have our Center for Industrial Mathematics and Statistics, which is a group of faculty, mostly in the math department, but they're all at least affiliated in some way with the math department, who have connections with industry. And sometimes these connections provide industrial sponsored projects where you actually would be working on a problem that comes from an industrial partner, and typically working with WPI faculty and partners in industry. And these are really fun and hands-on type projects. You get really to see applied math in action. And so you can also go to our SIMS website given here to see more details about that. We also have a BSMS program. So we have several master's programs listed here. We have applied math, applied statistics, and industrial math. And these are all great choices for our BSMS program. And so this is a program where students complete both the bachelor's and a master's degree, typically in 5 years. And there's a symbiotic nature doing this program, because you have some double counting, and the way you're timing things, you can get both degrees in 5 years, where typically a master's degree, if you go separately after an undergraduate degree, is usually a 2-year commitment. So this is a nice, efficient way to come out in 5 with a master's degree. So if you have any other questions, please don't hesitate to reach out to any of us or to take a look at our department web pages. I'll turn it back over to Professor Olson.
Okay, we're happy to answer any questions you might have about the programs, and we have Forrest here to also answer any student-related questions or student experience questions.
I'll jump in and be the icebreaker and ask one, because I have a question that I know I get a lot in our office from students who they worry that especially if they're talking to me about actuarial, because that comes up a lot as it is very unique and specific. They're worried that they have to declare and come in that way, and that it's hard to change majors, or if they don't come in that way, they fall behind. I know Forrest had talked about flexibility and changing majors, but I think if you want to maybe talk a little bit more about that, because I know that is something that students get nervous about, and we always try to highlight our flexibility. But sometimes I think hearing more about that is really helpful as they decide, I know I want this math, or I'm not 100% sure, but I want to know I can come into it later on if I didn't come in as a freshman.
I'll start with that. So like I said, when I was in high school, I was told that since I was decent at math and physics, that I should study engineering. And from that, I applied to schools as an electrical engineering major because I was told that one had the most math. And after a few days, I decided that 3-hour lab sounded not like my cup of tea. So I was talking to some friends that I had just made as a freshman, my parents, and I kind of was like, okay, well, I'm taking the CS class right now. It's pretty interesting. Maybe I'll be a CS major. A few more weeks went by, and I found that the thing that I was liking the most about my computer science class was the theory that we were discussing, and not necessarily all the programming. So at that point, I had joined Math Club. So I talked to some of the upperclassmen in Math Club, and I said, well, what does that mean I should major in? And they of course said, oh, that means you'd be perfect for a math major. You should take this class and see if you like it. So I did that, and I took the accelerated linear algebra class, and I found that this is something I really like doing. I felt that it was a really great environment. They made some good friends in that class, and I'm still friends with now. Kind of And so from there, I decided I wanted to absolutely be a math major. At the same time, I was a decent enough programmer that it wasn't something I wanted to completely give up, but I didn't want to take lots of the super intense software engineering classes because I knew that I didn't want to end up as a software engineer. So talked to some other people, and what they had suggested, oh, you should try the data science class and see if you like it. So I took one of the introductory data science classes and I liked it enough. And then I spoke with some professors about double majoring with math and data science. And they were like, yeah, this is actually something that the data science major is almost designed to do, is pick up a double major in CS or business or math. And through that, I kind of found what I wanted to do. I planned out my courses. And as I had kind of come to that conclusion, that was basically the entirety of my freshman year, I was able to register for all my classes and not worry about having to get into them or anything like that, because it wasn't like there were some things I had to do late, but there were still spots open, which was good. Another benefit of the math program is that it's a smaller major, so you don't really have to fight to get into classes, which is a really nice benefit, and it's a huge thing to not have to stress about. So through that, I kind of found that I wanted to do math. And then I guess specific to your part, you mentioned actuarial. The difference between a math and actuarial math degree is probably like 3 classes. Basically taking the actuary specific classes instead of some different ones. So that's something that you could pretty much decide like towards the end of your sophomore year, maybe even early junior year, and not have any issues about graduating on time. And I think something that you could probably do if you're in this position is try one of the actuary classes, because it will still count towards a math degree. It could be an elective, it could be an extra class. See if you like it, talk to the actuary professors, talk to some students, try one of the exams, see how you do, try the case competitions that were mentioned. There's lots and lots of opportunities to try things and see what you like.
That's always good to know. That is definitely the theme I'm finding when we have these department sessions. There's so many options, right? And I think the key, and you guys have all touched on it, is just talking, right? Talking to people, whether it's other students or your faculty, and just kind of finding the way and knowing that there's enough flexibility that even if you took a class, even if it's not the direction you want to go in, it's not going to not count for anything, which is always good. That's
and it's also worth mentioning that the first actuarial class, the first actuary specific course, is all the math that you need to do loans and bonds and mortgage amortization and all this kind of stuff. So that's super useful.
Yes, absolutely. That's fantastic. I know another question, and I think you did address this a little bit, but certainly, for students who come to us and say, well, I love math, I don't know where to start, but you guys did touch on all these research opportunities. And even Forrest, you talked about that as well. And we certainly, I know it varies from major to major, but are some of those research opportunities things that students can get into even as early as that freshman year or that first summer after freshman year, or is there any waiting, or what does that time frame look like for interested students?
So I can talk about from my experience. My freshman summer, I worked on a very applied math project. It was something in bioinformatics. I basically helped them kind of curate their data and get ready for it. The thing with math is that I have a book right next to me. There's a lot of it. There's a lot to hit on. That said, I'd say the most approachable thing that you can do before you have to crack open your 550 page book is talk about like math modeling. So modeling a system and seeing how like behavior changes under slightly perturbing some input variables or something like that. And that's something that you can pretty much take after like an ODEs class and a linear algebra class, which are both things that freshmen can very reasonably take. On top of this, WPI has a program, it's called the EREE, Early Research Experience in E-Term, which is over the summer. You get paid for it, which is pretty sweet. And it's specifically designated towards first year and sophomore students. That's like the target audience, to do a project sponsored by a professor at WPI. And those projects, like the proposals are submitted by faculty, and then there's like a huge list that you can apply from. It's like a 27-page document or something like that. And so the first thing that I was helping someone with their application for this a few weeks ago, I said, okay, Control F and type in math and see what comes up. And there were a couple of projects there, both in the kind of math modeling space with like a biological system. And then another thing that we kind of thought about was, so, you know, there's plenty of other things to think about. So, okay, let's see what there is in like kind of the physics side, physics, math, pretty intertwined. See what there is in the computer science side, math and CS very intertwined, and see if any of those projects seem interesting and apply to those as well. And by that point, we didn't even need to read the rest of the document because that was like 5 or 6 projects to apply to. But like we probably could have totally read the rest of it and been like, oh, that would be cool to apply to. And you have the skills from that from these classes. So absolutely apply to those. So that's what I would, yeah.
That's awesome. Thank you for sharing that. Okay, I have one. I don't want to steal the thunder from our students who are visiting, so feel free to jump in with a question, but these are questions that I know our students always ask me, so I'm taking advantage. But I do know, as you guys who are with us today, who have been admitted and are trying to make those final decisions, I'm going to steal Forrest again for this question, but you know, Forrest, what was it ultimately that helped you make your decision, and what led you to choose WPI? Maybe I think when students answer that question, sometimes there's relatable material in there that they're kind of going through the same thing that you went through.
Sure. So 3 years ago, I was, you know, a senior in high school and applying to places. I applied to 9 schools. Like I said earlier, I wanted to apply to engineering schools, and I didn't really want to go that far. So I'm from Southern Connecticut, so that restricted me to engineering schools in the Northeast/New York. So of the schools I got into, I toured them. One of them was the UConn, so state school, and some other places that I'm blanking on the names. And of all the places that I toured, I liked the collaborative atmosphere that WPI had the most. I thought that additionally, in case this hasn't come across, I'm a very nerdy person, and everyone here is also very nerdy. And like even people who you wouldn't think are nerdy, you get them talking about the right thing in their major. Oh, their 2 hours are gone. And I liked that a lot about an engineering school environment. Like I said, I'm from Southern Connecticut. WPI being about an hour and a half away is a decent distance. It means that if something were to happen, I could get home that day. However, that would require like a small amount of planning, but it's a good distance for me personally. I've made a lot of good friends here. I didn't really want to go to my big giant state school because I didn't think that it would be as like individualized type of attention for like, you know, working with professors and things like that. And I think that's something that a small school really has over larger schools, is that it's very easy to get individualized kind of working with professor one-on-one earlier than most institutions have probably at all. Like an MQP is a very unique thing that I don't really know of any other school that has something like really that similar outside of like an honors thesis. But for honors theses for like a bachelor's degree, you're taking that as a class with like 15 other people. And like at most you'd get like 1 10-minute, 15-25-minute block a week with your advisor, versus an MQP where it's, for me personally, I'm working with one professor. It's probably going to be having weekly, if not slightly more often than weekly, meetings about what I'm working through, and it will be a much more successful environment than like a typical kind of honors thesis type of experience.
Awesome. Thank you for sharing that. I appreciate that. This is good stuff. I do want to be cognizant of the time. So I am noting it is 5:45. I don't remember if we have a session coming up, but in case we do, I do want to just take a minute to thank those of you who joined us this afternoon. Thank you so much for taking some time to learn more about our mathematical science department. Thank you to Professor Olson and Professor Blaze, and of course to Forrest for sharing your thoughts and your knowledge. I know that if we have anybody who has questions we certainly will send them on over to you guys, but I appreciate that. And just wanted to give everyone a space to say if there's any closing remarks, but I just want to thank everyone for joining us this afternoon. All right, this is wonderful. Good luck to those of you making your decisions. My goodness, please know you can't choose the wrong school. You have many options. We would love you here. We know you'll be fantastic wherever you go. And thank you to my panelists for joining me today. I hope everyone has a wonderful afternoon.
Great. Thank
Thanks,
you so
everybody.
much.
Thank you.
Bye.